Hello, my name is Evelyn Torres, and I'm presenting on the semi-automated analysis of citations over a century of precipitation literature. Special thanks to my collaborators and my sponsors, Dr. Robert Hackenberg, Dr. Andrew Richards, Dr. Jessica Lopez, Texas A&M Online Research Experience for Undergraduates, and Los Alamos National Laboratory, Institute for Materials Science. There's a wealth of information within the scientific realm. Review articles and monographs help us digest this abundance of literature. Now, review articles, according to the ASME, organize, clarify, summarize existing major works, and provide comprehensive citations for relevant literature. And monographs publish works that focus on specialized topics. The people behind these review articles and monographs have power because they can convey which authors, journals, and studies they trust by including them in their references. By doing so, certain works are elevated and can become prominent while others die out. The goal of this project is to see which ones are prominent, which ones are dying out, and why. What are the schools of thought, the scientific structure of these fields, and the academic affiliations that contribute to this. This falls within scientometrics, which is study of the quantitative aspects of science, scientific communication, literature, and research. And here's an example of a review article. There's a little box identifying it as that. This project is related to bibliometrics, which is the quantitative method of citation and content analysis for scholarly journals, books, and researchers. Citation network analysis, which is a review method that seeks to map the scientific structure of a field as a function of its citation practices. And materials informatics, which employs techniques and tools and theories from data science and computer engineering to materials science and engineering to accelerate material product and manufacturing innovations, except in this case, the focus is not on innovations and products, but on literature of materials. So, addressing literature on materials, not material-specific problems. And here's a diagram showing a citation network analysis example. And it enables us to discover the hidden relationships with the citations. Case study, the century of precipitation literature. First off, what is precipitation? Precipitation is a heat treatment process that increases the strength and hardness of alloys. And it's shown here in the diagram. How does it work? Precipitates form within a matrix and act as an obstacle to plastic deformation by dislocation motion. And it's used for high-performance alloys, including materials like aluminum, iron and steel, nickel, and titanium. How are we going to accomplish this? Through a workflow. Phase 1 is gather 20 review articles from the 1920s to the 2020s that will be screened and down-selected for further processing. Phase 2 is gathering the reference list from those review articles and scraping them. There are 3 methods. The so-called easiest method, which is using the object identifiers, the DOIs of the articles. Method 2, which is using regular expressions to scrape them. Or method 3, which is using an already made scraped article mapping created by Dr. Jessica Lopez. Phase 3, parse citations into their respective parts: author, year, volume, page number, maybe title. Phase 4, create a matching algorithm to cross-reference sources cited among multiple review articles and volumes to see which are most prominent. Phase 5, make various charts exploring the relationships between data like reference type frequency, author frequency, identifying the last known citation of a dying paper. Phase 6, discussing results with subject matter expert. Expected results and future plans. So, expected results is producing graphs like this, and here is the author frequency graph for the article presented in one of the earlier slides. There is a problem with this graph though, and in general when encountering reference lists. There are minute differences between those citations, like take for example the highlighted name Deschamps. Deschamps is one person, but he shows up 3 different instances: Deschamps with an asterisk, Deschamps with his full first name Alexis, and Deschamps A. Because of those differences, he's recorded 3 different times and it messes up the results. So one of the future goals is to fix those errors to produce better output. Another obstacle I encountered thus far was while using the DOI method. It was supposed to be more efficient because there's a ready-made algorithm for DOIs that can parse them, but there are many paywalls that make it difficult. That's why in the future I plan to use regex to parse heritage documents, which are pre-born digital, and continue analyzing relationships in the data. Thank you for watching.